Welcome to your third week of asynchronous sessions. We're going to go over dividing polynomials, which goes over lessons 11 and 12, the different methods of dividing polynomials. So the objective for this unit is that students will be able to divide polynomials by using the long division algorithm and divide polynomials by linear binomials using synthetic division. So those are two different methods. We're going to learn each of those methods throughout this session. So before we start actually doing long division, let's go ahead and review how you do long division since we need to know how to do it in order to start. So we're going to divide 800 by 5 using long division. So that means we're going to have 800 divided by 5 would be another way to write that. So what this means is that when we do our long division, we have to put one number inside and we have one number outside. Well, sometimes it may be confusing as to which number goes where. The number that goes inside is always this first one before the division, or if you see it to where this is written as 800 over 5, it's always the top one. So the top one, or the first one, is the one that goes inside there. And then your other number, the one to the right of division, or the one on the bottom, goes to the left on the outside. So now remember, the way that we do this is we start with the first number here on the left inside. We see how many times our number on the outside goes into it. So how many times does 5 go into 8? Well, just once. So above the 8, we're going to put a 1. Now we're going to multiply. 1 times 5 is 5. So we're going to write a 5 underneath the 8. And then we're going to go ahead and subtract. 8 minus 5 gives us a 3. Now we're going to bring down the 0. So now we have 30. So 30 divided by 5 gives us 6. So we have that 5 goes into 36 times. So 6 times 5 is actually truly 30. So we're going to have a 30 there. And we're going to subtract 30 minus 30 gives us 0. Bring down our last 0. And then 5 goes into 0. Well, 0 times. We can't put a 5 into 0. So 5 times 0 gives us 0. When we subtract, we get 0. So we have no remainder here because we ended up with 0. So our answer is 160. So 80 divided by 5 is 160. The reason why we're reviewing long division is that one of the methods to solve division of polynomials is by using a long division format. So you need to know how to do basic long division so that we can use that for doing polynomials. So now we're going to learn how to do it for polynomials. So the polynomial long division algorithm, that's the algorithm that you use when you divide polynomials. So what it states is that if a of x and b of x are polynomials, that means that they're both polynomial functions, and b of x is not equal to 0, then values for q of x and r of x exist such that a of x equals q of x, which is known as the quotient, times b of x plus r of x, where r of x is known as your remainder. And another way to write that is that a of x divided by b of x equals q of x plus r of x divided by b of x, where q of x and r of x are also polynomials, and the degree of r is less than the degree of b. So let's say b has a degree, its highest degree is 2. That means that the degree of r has to be either 1 or 0. It can't be 2 or higher than b. It must be less than that. So we're going to now use this algorithm in order to solve some problems. So the first one we're going to do is we're going to take the polynomial x squared minus 7x minus 11, and we're going to divide it by negative 8. So remember, we want to take our first part there, and we're going to write it inside of our little division. So we got our x squared minus 7x minus 11, and then on the outside here to the left, we're going to put our x minus 8. So now the way that we decide how many times anything goes into it is we're going to start with our first highest degree here. So we have x squared. We're going to take x squared and we're going to divide by the highest degree outside. So x squared divided by x gives us an x. So we're going to put an x on the top here. Now we're going to multiply x times x and x times negative x. So x times x, we have x squared. X times a negative 8, we have a negative 8x. Now we're going to subtract. So we're subtracting this whole quantity here. So I find it easiest just to go through and change the signs of everything. So then it's just an addition problem down. X squared minus x squared gives us 0. Negative 7x plus 8x gives us a positive 1x. So now we're going to bring down our negative 11 here. So now if we're adding 0 to anything, that's as if the 0 just kind of goes away. So now we just have a 1x minus 11. So we're going to take our x here because it's our highest term. X divided by x gives us 1. So that means that we're going to put a plus 1 up here. Now we're going to multiply. So 1 times x, x. 1 times negative 8, negative 8. Then, like I said before, I find it easiest just go ahead and change the signs of everything. And then it's an addition problem. 1x minus x is 0. Negative 11 plus 8 gives us a negative 3. So now we have a remainder of 3. Okay. So we have a remainder of negative 3. So that means the way that we write our remainder is we go negative 3 over what we were dividing by, x minus 8. So our answer when we divide this is x plus 1 minus 3 divided by x minus 8. This is our answer when we do our division. Okay, let's move on to another example. So remember on the inside here we're going to put our first one, so x squared minus x minus 29, and to the left we're going to put x minus 6. So we're going to have x squared divided by x is an x. Now we're going to multiply. X times x is x squared. X times negative 6, negative 6x. Now we're going to subtract. So like I said, we're going to just change the signs and then it becomes an addition. X squared minus x squared is 0. Negative x plus a 6x is a positive 5x. So now we're going to bring down our negative 29. So now 5x divided by x gives us a 5. So we have a plus 5 now on top. Now we're going to multiply. 5 times x, we get a 5x. 5 times a negative 6, we get a negative 30. Remember, switch all your signs on that. And then add 5x minus 5x is 0. Negative 29 plus 30 gives us a plus 1. So then we have a remainder of 1 over x minus 6. So that means our answer is x plus 5 plus 1 divided by x minus 6. That is our final answer to this problem. Alright, so we've done 2 examples now. So I want you to try this practice problem here of taking x squared plus 10x plus 18 and dividing it by x plus 5. Remember, go ahead, pause your video, and try it out. And when you've done it, then come back and see if you got it right. So now that you've had a chance to do it, let's go ahead and let's go over it. So inside, we're going to have the x squared plus 10x plus 18. On the outside, we got x plus 5. So we're going to take our highest term, x squared, divide it by x. We get x. X times x, x squared, x times 5, 5x. Change our values here, so these are now both minus. Add x squared minus x squared is 0. 10x minus a 5x gives us a positive 5x. Bring down our positive 18. Take our 5x divided by x, we get a plus 5. 5 times x is a 5x. 5 times 5 is a 25. Go ahead, change all of our signs, and then add 5x minus 5x is 0. 18 minus 25 gives us a negative 7, so we have a negative 7 remainder over x plus 5. So that is our final answer, x plus 5 minus 7 over x plus 5. So now we're going to move on to synthetic division, which is another way of dividing two polynomials. So we're going to do synthetic division now. So the first row in the setup for synthetic division involves the value of a Place in a box followed by a list of all of the coefficients in order of descending degree of the dividend, including those with a coefficient of 0. So what we're going to do is we're going to have this box over here. We're going to put our value of a. So that's going to be like, let's say we're dividing by x minus a. It's whatever this a is. Now you have to be careful if it's a plus a. If there's a plus sign here, that means that your a is going to be a negative because this is minus here. Then let's say we have a quadratic of ax squared plus bx plus c. We're going to put those coefficients here next to it. So we're going to have our x squared coefficient, then we're going to have our x coefficient, and then we're going to have our constant coefficient. Okay? Then what we do is our very first one here, we bring it down, so we have a. Then we're going to multiply that times what we have here, and that's going to be what goes here. So we're going to multiply a times whatever our a value is times our a value up here. Multiply, and that's what goes here under the b. Add down, then multiply, add down again. Okay? So let's do an example to see what we get. So we're going to first put our a value in a box off to the side. So we have x minus 7 here. So since our minus sign is here, we're already good. So we're going to have a 7 here. Then we need all of our coefficients. Now, we want to make sure that we have each of the ones, we have each degree in our polynomial. If we don't, let's say this was just x squared minus 21, we would want to ensure that we put a 0 here for the x. We need a placeholder, so we use a 0 for each one. So x squared, my coefficient's 1. On my x, my coefficient is negative 3, and on my constant is negative 21. So I'm going to bring down my first coefficient, which is a 1. Then I'm going to multiply 1 times 7 gives me a 7. Then I'm going to add negative 3 plus 7 gives me a 4. Then I'm going to multiply. 4 times 7 gives me 28. Then I'm going to add, and I get a 7. So now, the way we write this is we start it with an x squared term. So that means our first number here is going to have one less of a degree. So instead of it being x squared, it's going to be an x. So we're going to have a 1x, which we can also write as x, plus 4. And then since we have just x to the first, this would be x to the 0, or just a constant. And then our 7 here on the right is our remainder. So that's plus a 7 over x minus 7. That is our remainder. So you can do synthetic division, or you can do the long division, whichever one is easiest for you. Let's do one more example of synthetic division. So we have our x minus 5, so that means my a value is 5. So I'm going to put that in its box. Then if you notice here, I don't have an x term. So my x squared, I have a coefficient of 1. Now I still need to put something in there for my x term, otherwise it's going to mess up all my calculations. So since there is no x term, that's as if its coefficient is 0. So I put a 0, and then I'm going to put my constant of negative 28. So remember, I bring down the first term, multiply, 1 times 5 is 5, add, I get 5, multiply is 25, and then add again, and I get negative 3. So remember, we start with 1 less, so this was x squared, so that means my first one is going to be an x. So I'm going to have x plus 5 minus 3 divided by x minus 5, and that is what I get when I do my division. Alright, so now let's see if you can do one. Go ahead, use the synthetic division and see if you can do it. Remember to pause the video and do it, and then when you're done, come back in. Alright, so now that you've had a chance to do it, let's go ahead and go over it. So we need to be careful on this one, because see here how we have a plus 8? That means our a is going to be a negative 8. Then we have x squared coefficient is 1, x coefficient is 14, and our constant is 38. So now what we're going to do is we're going to bring down that 1, multiply 1 times negative 8 gives us a negative 8. Add down, we get a 6. 6 times negative 8 gives us a negative 48. So we have that the 6 times 8 gives us a negative 48. Add down, and we get a negative 10. So that means that you should have ended up with x plus 6 minus 10 divided by x plus 8. That should have been your final answer. So remember, you can use either method. So in order to get your points for this, go ahead and go to the announcements, click on the Google form link, answer it, and submit it. Remember, if you still have any questions, contact me by email, phone, or message.